Alright everyone, welcome to our channel. We have been talking about surds, operation with surds. We have been discussing and explaining what operation with surds is all about. We have talked about how to express surd in its basic form. We've talked about how to identify similar surds. We've talked about how to express a surd in its conjugate, how to find the conjugate of a surd, and how to express a surd as a single surd. Okay, so or a given expression as a single surd. So these are foundational things that, please, if you are just stopping on this video, please do well to go back and search for those videos so that you can watch and understand where we have been coming from. All right, so it is based on that foundation we'll be moving straight up to learning how do we add and subtract surds. All right, so without wasting much time, let's just look at some questions. I believe questions will help us better, will give us a clearer understanding on how to do this. All right, so whenever you have to evaluate questions like this, the first thing, just like what we did, was to look at, you will look at the rational for irrational form, just like the root form. This is root 32, this is root 8. Are they in their basic form? So the first step you follow, the first one is check. You have to check if the root form or the irrational part, the root form, let me call it root form so that you'll be able to remember this. The root form is in its basic form. Okay, so you have to check. In other words, is it possible for you to see two factors or more that has a perfect square root, or there is a perfect square? So when you are able to check that, then that will help you to see. So because for you to be able to add or subtract any surds, it must first of all be in their basic form. You must express all of them in their basic form. This is one of the things that will make it easy, or did I say easier for us. So we have to go and check. Like this one, obviously I can see 4 times 2 there. So I can, and 8 having two factors, 4, and having another one 2. I can see that this 4 it has a perfect square root. So that means, of course, obviously this one is not in its basic form. Then 32 also, obviously that's 16 times 2, right? Yeah. So 16 times 2 also, this is a factor that also that is also having a perfect square root. Okay, so that means obviously this one also is not in its basic form. So what do? I simply take them to their basic form first. That's the first thing to do. So you take them to their basic form. Root 32 is same thing as saying root 16 times 2. Okay, which is same thing as from our rule. We talked about the rules of surds. Okay, this is 4 multiplied by root 2. Okay, and when this is done, this is 4 root 2. All right, so this is now in its basic form. Then the other one also, which is 3 root 8, you pay attention to the root form, this very root. That's where our attention should be focused on. So this is 3 is multiplying that, so this is 4 times 2, you see, and these are going to have 3 times root 4 multiplied by root 2. Okay, if this is done properly, we are going to have 3 multiplied by 2 multiplied by root 2. All right, so what's going to be the answer? We are going to have it as a 6 root 2. All right, so we can see, what can we observe here? We can see that the two of them now are in their basic form, and we can also see that they are similar. They are similar. We have 4 root 2 alongside 6 root 2. You see, their root form is the same, root 2 root 2. So root 2 equal root 2. So means they are similar. These are similar surds. So these are similar surds. And we say that when two surds are similar, two or more surds are similar, you can add them, you can subtract them. All right, you can perform the addition and subtraction mathematical operation on them. All right, so what do we do now? We now go back to the question. The question is saying root 32, that happens to be our 4 root 2 is being added to 3 root 8, which by our expression now in its basic form is 6 root 2. Okay, so what do? We simply add them together. Now you see those outside is the one, these two numbers that are outside that are multiplying this root form, they are the ones you are going to add. When you add them, then you repeat just one of the root. I believe you are understanding it. Okay, so you just repeat one. This is the first, this is a one way to do that. So it's going to be 4 plus 6. That's going to give you 10. Then you just repeat one of them. Another way to look at it is to factorize. You know, you can have 4 root 2 plus 6 root 2. Alright, so you look at what and what is common. You see that root 2 is common to both of them. If you bring out root 2 that is common, okay, what will be left to, if you divide 4 root 2 divided by root 2, you are going to have, this is what you are doing. You are saying 4 root 2 divided by root 2. Root 2 cancel root 2 here. Are we together? So we are left with 4. So we have 4 plus the same thing, 6 root 2 divided by root 2. Root 2 cancel root 2 here. We are left with 6. Later we'll look at division, but this is just an idea to show us what we are doing when you are factorizing this. Alright, so when you do this, you are going to have root 2 into 10. And mind you, whenever you have an expression that does not have a root form like this is multiplying, you don't multiply, you don't take this 10 inside. When you do that, you are simply taking it to a single surd. You remember when we discussed single surd? And when it's going in like this, it will not go in as 10, it will go in as 100. I believe you remember that. So please, don't be tempted to say 2 times 10. No, that would be wrong. So what will happen is going to come as a coefficient of root 2. It's going to come as coefficient of root 2, which is going to be 10 root 2. Alright, so I believe you know what coefficients are. It's just a number or an expression or a term in front of a particular number of concern. For example, if I have 3x, the coefficient of x here is 3. If I have or plus 3, because I can have 7x squared, and I say what's the coefficient of x squared? The coefficient of x squared here is negative 7. So whatever is in front of that very number that of concern happens to be the coefficient. So that's what we are saying in this case also, that whenever you have an expression like this, it is good for us to understand that this 10 will not multiply this root 2, rather it will come as a coefficient. Alright, so that will be the final answer to this problem. I believe we are understanding this video. Let's have some more questions even as we move further. I believe this is very easy for us to do. Okay, let's quickly look at another one. Alright, look at another question. We have to evaluate 7 root 3 and 75 root 75 rather. Alright, so how do you get this? It's obvious. You have to check. Is this one in its basic? Obviously, this is already in its basic form because I can see that 3 will no longer, in fact, itself is a prime number. So it's also having 2 factors, itself and 1. But this, I'm not sure. We have to check. Can 75 be expressed into 2 factors such that one of them will be a perfect square root? We have a perfect square root. Alright, so let's divide. I can see it's obviously 75 divided by 5. Let's see. We divide it by 5. What are we having? Okay, 15. What about 25? No, sorry, it's not even divided. I'm supposed to be dividing by those numbers that are having a square root. So if we do, let's say 25. I believe 25 should serve. Okay, that's 3. All right, so that's going to give us 25 times 3. All right, so I'm doing this for us to be able to see what to do. All right, so this is the same thing I say. So you can come and deal with this separately. You can deal with root 75 separately, which is 25 times 3. Okay, if this is done, this is root 25 multiplied by root 3. Alright, so this is going to give us 5 multiplied by root 3, of course, which is 5 root 3. Okay, alright, so this one is now in its basic form, and this also is in its basic form. So what are we asked to do? We have to do 7 root 3 minus 5 root 3. Alright, I told you, since they are similar, can you see they are similar? So you can subtract them. 7 minus 5, that's 2, then root 3. You see, it's very simple. Alright, or you can simply say 7 root 3 minus 5 root 3. You check what is common. Root 3 is common to them. Okay, in this, that's 7 minus 5. All right, so root 3 into 2. 7 minus 5 is 2. Just like I told us earlier, you don't say root 3 times 2, then you have root 6. No, it's going to come as the coefficient. So it's simply root 3 times 2. Okay, when this, because this one is not having roots also, so it's not going to multiply, it's going to affect this because they are not similar. That's true. So this is 2 root 3. All right, so let's just bear that in mind. Very important. If I have root 3 multiplied by root 2, you see both of them are carrying root, so the law can apply to them. Remember the law, 3 times 2. Remember that law. That's our first rule. Okay, then this is going to give us root 6. You see, this is different from this. Please, I want us to bear this in mind. This one is not the same as this, because this one is not having root, but this one is having root. So we can apply the surd rules to this one, so that we can bring them under a common umbrella of a root. Then they can multiply each other and have this. But in this case, both of them are not similar. You see that, no, not even similar. They are not like terms, rather. Yeah, I think that's a proper way to say that. They are not like terms. And we can say that this is 2. So what you can do is simply to just come as a coefficient here. I believe we understand. So whatever the coefficient is, these two will come and multiply. So the answer to the problem that we have to solve is 2 root 3. I believe we are understanding this this problem. We are going to solve some more questions so that we can gain mastery and also perfect areas where we are still getting confused. Thanks for watching our video. Please like, subscribe, and share. And please stay tuned to our channel as we bring more videos to you that is going to bless you. Going to, of course, is going to worth it. It's going to be, you are not going to waste your time. If you are watching our videos, because we are going to take you through the rudiments and also ensure that we go bit by bit. Even to somebody that is just starting mathematics, will be able to understand what we are doing. So I believe we have enjoyed this. So let's look at some more questions as we progress. All right, so this is another question. In this case, we are to evaluate 3 root 48 minus root 75 added to 2 root 12. All right, so just like I told us earlier, the first thing to do is to express them in their basic form. We look at the root form, you can see that obviously they are not in their basic form. So we need to quickly trash that. So we can undo them one after the other. Let's deal with 3 root 8. All right, so we have to look at how do we get out of this? How do we get out of this 48 factor? One of these factors have to have a perfect square root. So just like what I told you earlier, you start using numbers that are perfect square roots to be dividing them. Like for example, we have 48. We divide it by 4. 4 happens to be a perfect square root. Okay, that's 12, right? Okay, so 4 times 12 is 48. Okay, let's look at more. We have 48 also. Another perfect square number is 9. Okay, divided by 9. Okay, it will not go. 48 divided by another one is 16. Oh, good. 16 times 3. All right, that's good. I think this will help us. 16 times 3 will be good. The reason why I have to move further is because I'm looking at, by the time you are able to get one, the second one should be such that you cannot break it further. That's a very good one. When you're able to have that kind of factor, it's going to help us. So this is root 16 multiplied by root 3. So which is 4 root 3. Okay. Then again, we look at root 75. Of course, we have done root 75 before. That's 25 times 3. So this is 25 times 3, okay, which is root 25 multiplied by root 3, which is 5 root 3. All right. Then we have 2 root 12. Root 12 is something as saying 2 root, this is 4 times 3. 4 times 3 will give us 12. Okay, so which is 2 times root 4 times root 3. All right, so this is going to give us 2 times 2 times root 3. All right, and the final answer for this one will be 4 root 3. All right, so let's now bring everything together. The answer for when we express this in its basic form, we are able to have 4. Okay, there is 3 outside here. Yeah, there is a 3 outside. That's very important. Thank God I'm able to see this. No, there is 3 here. So we must not forget that, because that 3 also, just like in the case of 2 that we have here. All right, so it has to be 4 times 3. Yeah, that's good. That's a good observation that you have to notice. Despite you must also look at this. Once you are through with this one, you must not leave it alone. All right, so we are going to have, so this answer really is going to be 12. It's going to be 12 root 3, because this 3 that was outside before multiplied by this 4 that you have just brought out, they will multiply each other since they are like terms. All right, so we are going to have 12 root 3, okay, minus 5. This is minus 5 root 3, okay. Then the last one, we are able to have plus 4 root 3. Okay, so they are similar sorts, right? Yeah, they are all similar, because I can see root 3, root 3, root 3. So what do? I can, if I like, I can bring out root 3, factorize it, so that I can see clearly. I'm going to have 12 minus 5 plus 4. See, root 3 is out. Okay, if you open this bracket again, if you remove it, you are going to, the 3 will appear back. All right, so what was 12 minus 5? That's 7, right? So 7 added to 4, that's going to give us 11. All right, so we have root 3 into 11, that is multiplied by 11, and that will give us 11 root 3. Okay, I believe we are understanding this expression, this question, and the explanation is clearer enough. So let's look at more examples. Look at this also. This is somehow similar to what we have done, but just for emphasis sake, for us to be able to see. So very quickly now, we'll be moving faster now, because I believe we are gaining mastery. So 4 times 3, okay, this is going to give us 2 multiplied by root 4 multiplied by root 3, okay. So what do we have? It's going to give us 2 times 2 times root 3. All right, so this is going to give us 4 root 3. Okay, that's done. Then we also have 3 root 48. Root 48. I think we there was a time we actually handle cases like this. So let's, just for the sake of 48 now, if we divide it by if we divide 48 by 4, what do we have? You see, it's still giving us 12, and I know that 12 is still having 4 times 3, so I will find another one. So 48 divided by, the next one is 9. Can it go? No. Okay, so 48 divided by another perfect square, divided by 16. Yes, okay. So I will say this is going to give me 3 square root of 16 times 3. You see, this is how you keep on doing this. So we have 3 multiplied by the square root of 16 multiplied by the square root of 3. Okay, that's 3 times 4 times root 3, which is 12 root 3. Okay, then the last one is root 75, which is 25 times 3. Of course, we've done that before. So this is going to give us 5 root 3. All right, so what do we do next? We bring them together. All right, so the first one is 4 root 3 added to that gave us 12 root 3, then minus 5 root 3. Okay, so you can add it. I told you these two is what you will watch out for. So 4 plus 12, That's 16 root 3 minus 5 root 3. They are still similar. So what's 16 minus 5? That's 11, right? So 11 root 3. So I believe we are getting this. We are getting this. We are getting this. We are getting it. Yeah. It's not something difficult. It's not something difficult. Look at another question. Let's just see this. Question 5. Okay, very quickly. Now we'll be going faster since I believe we are understanding it properly. Okay, so this is 5 into 4 times 3, right? Okay, this is 5 into square root of 4 multiplied by square root of 3, which is 5 times 2 times root 3, okay, which is 10 root 3. Okay, this is 10 root 3. Then we also have 4 root 72 equals this. So let's quickly get, how do we get 2 factors for 72 in which one of them should have a perfect square, right? So let's quickly do 72 divided by 4. Okay, that's giving us 18. I can still see that 18 is having 9 times 2. So if you can pick it like that, no problem. But can we just go 72? Let's see. 72 divided by 9. You know, after 4, 9. Okay. Good. It's giving us something about, I can still see this one. I'm not still comfortable. Let's see 72 again. Divided by 16. Okay, to not go. Okay, so should we just let's just start with let's say divided by 4. You know, sometimes you may not quickly get. Okay, let's just do this. So I see that this will work for me. To actually work for me. So this is 4 times 18, right? Yeah, that's what we have. Sometimes when you break it down like that, it helps you to see another one that can be easily seen. Whether you see it, because I know that 9 times 2 is 18, so I can easily get that from the first division that I've made. So this is 9, this is root 2. Okay, this is going to give me 4 times 2 times 3 times root 2. Okay, this is going to give me, this is 8, this is 24, right? 24 root 2. Okay, then we also have 3 root 18. 3 root 18 is 3 root 9 times 2, which is 3 times 3 times root 2, which is 9 root 2. All right, then I have 2 root 75, which is 2 root 25 times 3, of course, which is 2 times 5 times root 3, which is 10 root 3. All right, so what do? We simply just bring them together. I have 10 root 3 plus from the question added to 24 root 2, then minus 9 root 2, then added to 10 root 3. All right, so what do? This plus this is going to give me 34. No. You collect like terms. I like this. You have to collect like terms. This and these are not similar, you see. You can't add them. So you go and look for the ones that are similar. So I can have, so collect like terms. I have 10 root 3 plus another 10 root 3. Okay, these two are similar. All right, then plus I have 24 root 2. Okay, then minus 9 root 2. So you see, you must bring, you see, just like I told us earlier, if they are not similar, you cannot add them. So you see, I can easily add this one. 10 plus 10, that's 20 with this, then which is plus. All right, so 24 very quickly. 24, if you take 24 minus 9, that's 15. So you are able to have 15 here. 15 root 2. Okay, so there's nothing you can do to this any longer because they are not similar sorts anymore. So this is root 3, this is root 2. Now, you see the mistake you have to watch out for in this case. Don't be in a hurry to add. Watch the roots. The roots must be the same. that's what qualifies them to be similar surds. Just like I told us earlier that before you can say a surd is similar, the root form must be the same. So like in this case, the first thing to do is to watch, then you collect the like terms. We have 10 root 3 added to 24 root 2 minus 9 root 2 plus 10 root 3. So now you bring all the ones having similar roots together. That's what we have done here. 10 root 3 plus 10 root 3. You see, I've picked this and I've picked this. Okay, because they are similar. Then later I went further to pick 24 root 2 minus 9 root 2. Alright, so this and this can be added together. That gave us 20 root 3. 24 minus 9. That gave us 15. So 15 root 2. Alright, I believe we understand this, this video. And as we are moving step by step, I believe we are also gaining mastery gradually. Don't forget that similar surds are the only surds you can add or subtract from one another. And also, it's very good to watch and collect like terms accordingly before you perform the operations. All right, either positive or negative, depending on what the examiner is asking us to do. All right, thank you for watching. We look at another question now. Then we wrap this up. All right, this is question 6. Let's get down to this. Okay, just like we've said earlier, what do? We quickly take them to their basic form. All right, so just bring them one after the other and treat them accordingly. All right, so how do I get the basic form of this? It's obvious this is multiple of 5. So let me bring out my calculator. I told you it's very easy. Just say 2. We have 150. So 150 divided by 25. Okay, that's 25. That's 6. All right, so this is same thing as saying 2 into 25 times 6. Okay, which is equal to 2 times root 25 times root 6. Okay, that gives us 2 times 5 times root 6, which is 10 root 6. Okay, that's done. Then we look at 96 again. So you start dividing it by perfect square root numbers. So 96, if we divide it by 4 initially, we have 24. Okay, the 4 looks big to me. Let me try another one. Let's say 96 divided by 9. Okay, you see it's not a factor. All right, so 96 divided by, the next one is 16. Okay, yeah, that's 6. That's good. All right, so I can have this as 16 times 6, all right, which is square root of 16 multiplied by square root of 6, which is 4 root 6. Okay, all right, then the next one is 2 root 24. All right, so how do I get the factors such that one of them will be a perfect square root? So just bring out your calculator. 4 divided by 4. Okay, that's 6. All right, so which is also good. The same thing as saying 2 multiplied by square root of 4 times 6. So this is 2 multiplied by this, multiplied by root 6. So that's 2 times root 6, which is 4 root 6. All right. So we are true. We've been able to express each of these expression in its basic form. We have taken them to their basic form. So the next thing is to check, are they similar? If they are similar, then we can perform either subtraction or addition operations on them. All right, so the first one we have is 10 root 6 minus the 96, which is 4, another 4 root 6, then minus another 4 root 6. Okay, so when you do 10 minus 4, of course you are going to have 6, right? So 6 root 6 minus 4 root 6. All right, so sorry, minus 4 root 6 minus 4 root 6. All right, so when this is done, what happens? You simply subtract 6 minus 4. That will give you 2, and then root 6. I believe we are enjoying this, and it's nothing hard at all. Let's take another question. Now look at this question. We are having this is not, this is in decimal. Okay, so how do we handle a question like this? All right, so remember in our elementary maths, when we have something like this, I can move a point and have this, right? And I have 16 over 10. See, so this is like 16 over 10. Then on the other hand, I have 0.4 over 1. If I move here, I'm having 4 over 10. All right, so this is what I have. Then this 5 is now multiplying them, so I have 5 into 16 over 10 plus 4 over 10. So this is what we are having first. No, don't worry about the root. We are going to come back, but I just want to show us this. So when you open this bracket, what are we going to have? It's going to be 5 multiplied by 16 over 10. Is that not? Okay. Plus another 5 multiplied by 4 over 10. So I'm just showing us something, just an idea. This is 2. This will cancel this. Also 2. This in this is 1. This in this is 8. Excuse me. And this in this is 1. This is 2. So we have it as 8 plus 2, right? Which is 10. This is just from our elementary math. I believe we are getting it. All right. So, but in this case, we are having roots on them. Yes. So let's look at it one by one. This is 1.6, then plus root of 0.4. All right. Then we have 5. So if I open this bracket, what am I going to get? I'm going to have 5 into 1.6 plus 5 into 0.4. Okay, this is what I'm going to have. Are we following? All right. So now, what do? I want to apply this principle. Remember, when you are taking a number to single surds, when it's returning inside, it goes in squared, right? All right. Please, if you are just watching this, please kindly go back and look. We have done a video on how to express numbers as a single surd. Please, an expression as a single surd. Please kindly find that so that you can have an idea of what we are doing. Okay, so this is, you agree with me that this is the same thing as saying 16 over 10, then multiply by 25. Okay, why this is also square root of 4 over 10 multiplied by 25. If I decided to take the 25 in, what I'm going to have. So if I do 2 here, 5 here is 2, 5 here is 5, okay, 2 here is 1, 2 in 16 is 8, okay, for that. If I do 5 here, it's going to give me 2, 5 here is 5, 2 here is 1, 2 here is 2, all right. So I'm left with here, I'm having 8 times 5, which is 40, added to, and here I'm having 5 times 2, which is 10. So eventually, I'm having root 40 added to root 10. This is what I have. Now, this is already in its basic form because I can't get 2 factors of 10 such that one of them will be a perfect square. I can't get that. So that means this is good to go. All right. So, but this, I can see 4 obviously. So meaning I can take root 40 to basic form by saying square root of 4 times 10, okay, which is going to give me square root of 4 multiplied by square root of 10, which is the same thing as saying 2 times root 10, which is a 2 root 10. All right, so this is what I have. Now what do I do next? I bring them together. I'm having 2 root 10 added to root 10. Good. So they are similar. You see, their basic form, they are in their basic form, number one. Number two, they are also similar because their root form is the same, root 10, root 10. So we can add them. Don't forget, it's like there is 1 here. You know, just assume 2 plus 1. Yeah, just assume it that way. So 2 plus 1, that's going to give you 3, then root 10. So this is the answer. Another way to do it is to factorize. You can bring root 10 out into root. This will give you 2. This one will give you plus, this is 1. Root 10 divided by root 10 is going to give you 1. So you are going to have root 10 into 3. So that's going to give us 3 root 10. All right. I believe we enjoyed this video. I believe this is not hard at all. Please, you can just pause it, look at it, and drop. If you have any question, please kindly drop it in the comment section. And you see, don't forget how I started from this. This is just to give us an idea of what I'm about to apply here. All right, so this just helps us to be able to see how this thing moves. You see, when you have two fractions like this and there is a number multiplying, it will multiply this, it will also multiply this. All right, it's not only this one, it will multiply both of them. All right, so doing that, we're able to reduce this to 10. Fine. Then we brought the idea to this. So we have 1.6, which is 16 over 10. Then 5 is going in now as a single surd. Is going to enter as 25. Remember that. We discussed that earlier in our previous video. So when you now simplify, we are able to get it as 40. And also regarding this, the 5 also entered as 25, and we simplify properly, we are able to have the final answer to be root 10. So we are now take this one to its basic form. That's how we are able to have 2 root 10. Then 2 root 10 plus root 10 gave us 3 root 10. All right, this is very important. We need to understand this. Just like when you say 2x plus x. You see, it's like there is 1x. You know, you say 2 plus 1, that's 3x. So it's the same thing, very similar to algebraic expressions. They have there's this peculiarity about them and similarity. Whenever you are dealing with surd, you know, when you have your understanding in algebra will also help you so much in this matter. All right, so I believe we are getting this. I believe we understood this problem. Let's have one more, then we wrap this up finally. Thank you very much for watching. Let's take another question. All right, so this is the last question we'll be solving regarding the addition and subtraction of surds operations. So this is another a given one that is quite different from what we have learned. This one they defined what the roots are themselves. The examiner actually defined them. They gave us what they want us to use. You see, this one, our expression is not going to be the way it used to be. Giving all this, root 2 to be 1.414, root 3 to be 1.732, root 5 to be 2.236. We have to evaluate each of the following correct to 3 significant figures. All right. So one of the things, what we need to do is you try as much as you can to express these problems in terms of these root forms. All right. So you now think, how can I break it down such that each of them we have, I can break it down to have, you know, in terms of root 2, in terms of root 3, in terms of root 5. So for example now, 40, I begin to look at, okay, what can I do to 40? How can I break 40 down? I know that I can see 4, yes, I can see multiple of 2. I can say this is 2 times 2, right? So 2 times 2 times 10 will give me 40. But in the given sort, there is no 10 there. So I have to still keep breaking it. This is 2 times 2 times, I can see 5 times 2 here, so times 5, you see, such that you have to break it down to a surd that is going to be, that is going to be similar to the one that is given. You must be able to do that because you can't bring in another value apart from what has been given to us. So you see, you're having it like this. You have root 2 multiplied by another root 2 multiplied by another root 2 multiplied by root 5. You see, this is what we are able to have. Now you have successfully converted root 40 to 2 times 2, which is 4. 4 times 2, 8. 8 times 5, 40 now. You see? Now it's the same as this. So why do we have to do it like this? Because we must stick to these root forms that were given to us. These values. You must stick to them. So that's why you have to learn how to express them. Think on how you can break this down so that it can have either root 2 or root 3 or root 5, depending on how you are able to do that. But you must be able to make sure that all these roots appear. Any other number that appear other than this will not make us to get the answer. All right. So what do we do? This is 1.414. It's being multiplied to 1.414. It's also being multiplied to 1.414. Then root 5, which is 2.236. Okay. So let's quickly bring up a calculator and see. We have 1.414 times 1.414 times 1.414 times 2.236. All right, this is 6.322. Let's call it 322. 6.322. But the question says to 3 significant figures. All right, so let's count. 1, 2, 3. All right, so this is the third significant figure. This is not okay up to 5, so we discard that. So that's going to be 6.32. all right, that is going to be the answer for that. All right, then for the one of root 500, I believe we are understanding this. So for the one of root 500, obviously this is root 5. I can see 5 times 100. Okay. I can also see 100 is 10 times 10. So I will keep on breaking and breaking until I have gotten something that will give me the roots that have been provided by the examiner. All right. So in 10 times 10, I can also see 5 times 2. Did you see that? All right. So I'm going to make sure I express that 10 as 5 times 2. I mean as 5 times 2. So I have 5 multiplied by, this is the first 5 times 2. Then multiply by another 5 times 2. Okay. So if that is the case, so it's just, the rest is just, I have this. By the law, you can split them just like the way I'm doing. This multiplied by root 5 multiplied by root 2. Okay. All right. So what do? We start bringing in their values. They say 5 is 2.236. Okay. Multiply by another. Multiply by another 2.236, then multiply by root 2 now, which is 1.415, then another root 5, so multiply by 2.236, then multiply by 1.414. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. So what do we do? Just bring our calculator to quickly express this. All right. So showing our calculator now, we have 2.236 multiplied by 2.236 multiplied by 1.414 multiplied by 2.236 multiplied by 1.414. All right, that is giving us 22.352. 22.352. So we have 22.352. All right. So to three significant figures, 1, 2, 3. This the fourth one is more up to 5, so it's going to give us 22.4 to three significant figures. All right. So I believe we are understanding this. This is just how to solve this one. Let's take the last one, which is the C. Root 10 divided by 7 root 2. Right. So the C part of this particular problem is saying that what is 10 divided by 7 root 2. Right. So in this case, you see that we have 10, of course. Then we have 7 multiplied by root 2. Root 2 is giving us 1.414 already by the examiner. Okay, so let's quickly do this and see what we are going to get. Let me position my calculator properly. All right, so we have 7 multiplied by 1.414. Okay, that's 9.898. 9.898. Okay, so that's 9.898. Okay, so we now say when we bring our calculator, we are going to have 10 divided by 9.898. That's 1.0103, 1.0103. So to three significant figures, that's 1, 2, 3. So which is 1.01. All right. So thank you for watching. This is all we have under all these questions we have. This is the last one. Thank you for watching as we'll be going towards multiplication and division of surds. That's going to be our next video. Thank you for subscribing to our channel, and thank you for liking and sharing. Please do well to continue to do that as we bring to you more video that is going to bless you and also bless you with information and understanding that is required to actually sit for an exam and pass with flying colors. All right, without wasting much of our time, I want to thank us for your time and patience. All right, so we meet again in our next video as we discuss multiplication and division of surds. Thanks for watching.